Hello everyone and welcome back to my channel. Today I'll be talking about eutectic systems, specifically the lead-tin phase diagram. So eutectic simply means easy melting, and this is taken from the Greek word eutectus. If you look at this phase diagram here, this temperature 237 degrees Celsius is the melting point for pure lead, and 232 degrees Celsius is the melting point for pure tin. Now this horizontal line represents the eutectic temperature, 183 degrees Celsius, which is the lowest temperature at which the mixture of lead and tin will melt. Also, this value here, 61.9 weight percent tin, that's called the eutectic composition, and it's the only composition for which the liquid would cool down directly into the two-phase alpha plus beta region. And the microstructure usually shows alternating layers of alpha and beta within the grains. It looks like this. The dark regions represent the lead-rich alpha phase, and the light regions represent the tin-rich beta phase. Now let's go through an example. So it says we've got 61.9 weight percent tin, that's the eutectic composition, at 150 degrees Celsius. So first you draw your horizontal line to represent the temperature, 150, and then you draw your vertical line to represent the composition. Where this intersects will then tell you how many phases you've got within the microstructure. And because this is within the alpha plus beta phase, we have two phases present. So to get the composition of alpha and beta, you have to project these lines down to the horizontal axis to get C alpha and C beta. So the composition of alpha is approximately 10.5 weight percent tin, and the composition of beta is approximately 98.5 weight percent tin. So now you have to find the weight fraction. And the weight fraction of alpha is S divided by R plus S. And that's, so S here is C beta minus C naught divided by R plus S, which is C beta minus C alpha, and that's approximately 0.4. So to get the weight fraction of beta, it's R over R plus S, which is C naught minus C alpha over C beta minus C alpha, which then gives 0.58, or you could just subtract 0.42 from 1 just to make sure that answer is correct, because the weight fractions always add up to 1. So the composition of lead and tin, the composition of tin and lead is very important for making a solder, because especially the eutectic composition. Now soldering refers to the joining of two or more metals, and you usually have this component in the middle which has a significantly lower melting point compared to these two which are being joined. So with this, once you apply heat to it, this solder, which is usually at the eutectic composition, melts much quicker than these two components. So then it forms that joint between the metals. So thank you for joining me. Like and subscribe to my video. And if you have any questions, leave your comments in the comment box. Thank you and see you later.